This provides the simulation codes used to generate the results and figures shown in the paper titled Modulation Options for OFDM-Based Waveforms, Classification, Comparison, and Future Directions. The paper provides a comparative study on the performance of different modulation options for orthogonal frequency division multiplexing (OFDM) in terms of their spectral efficiency, reliability, peak-to-average power ratio (PAPR), power efficiency, out-of-band emission, and computational complexity. The modulation candidates are classified into two main categories based on the signal plane dimension they exploit. These categories are 1. Two-dimensional 2D signal plane category including conventional OFDM with classical fixed or adaptive QAM modulation, and OFDM with differential modulation OFDM-DM, where information is conveyed in changes between two successive symbols in the same subcarrier, or between two consecutive subcarriers in the same OFDM symbol. 2. Three-dimensional 3D signal plane category encompassing a. Index-based OFDM modulation schemes which include 1. Spatial modulation orthogonal frequency division multiplexing SMOFDM, where information is sent by the indices of antennas along with conventional modulated symbols. 2. OFDM with index modulation OFDM-IM, where the subcarrier's indices are used to send additional information. B. Number-based OFDM modulation schemes which include OFDM with subcarrier number modulation OFDM-SNM, in which a number of subcarriers are exploited to convey additional information, and C. Shape-based OFDM modulation schemes which include OFDM with pulse superposition modulation OFDM-PSM, where the shape of pulses is introduced as a third new dimension to convey additional information. Based on the provided comparative study, the relationship and interaction between these different modulation options and the requirements of future 5G networks is discussed and explained. The paper is then concluded with some recommendations and future research directions.